Good evening, everyone. So we are about to start the session. My name is Ashwin Ratan Sabapati, and I am an operations engineer at Cisco Labs Technology, and I will be the host for your session today. So without further ado, I would like to welcome you all to the fourth edition of PerfUp. And this session mainly focuses on improving business through performance engineering. PerfUp is powered by Cisco Labs, and today we have two great speakers to see how performance engineering helps in business improvement and growth in a startup and also in the enterprise context. So, before we go into today's session, into the agenda of the day, I would like to give all of you all a bit of an introduction of what PerfUp is about and how we've started. So PerfUp is basically an initiative that brings together the best minds in the software engineering arena to share knowledge on the latest trends and discuss best practices in the field. Each PerfUp event will feature a panel of expert speakers who will speak on their knowledge and experience in the area to inspire individuals to tackle performance engineering. So that's a bit about PerfUp. And as I initiated with, this is the fourth edition of PerfUp. And let's go on to today's agenda. So before we go into the sessions today, I would like to introduce your speakers for tonight. And we have with us Yusuf Maktoum, uh, an asset of our own. Yusuf is a senior manager in quality engineering at Cisco Corporation. He brings over 13 years of experience in the IT industry, specializing in quality engineering. His areas of expertise include architecting QE platforms, strategizing testing solutions, and leading multinational quality engineering organizations. At Cisco, a Fortune 100 company, Yusuf is responsible for quality engineering, open source adoption, test infrastructure management, and performance engineering. His goal with all of his teams is to consistently discover solutions that deliver high quality business capabilities at speed. And with Yusuf, next we have with us today Ranil Veerasinghe. And Ranil is the Assistant Director, Software Quality Engineering at Cambio Software Engineering. Ranil too is currently leading the performance engineering and functional automation practices at Cambio, and he brings about 15 plus years of experience into software quality assurance and engineering, where he holds expertise in performance engineering. He has worked in several leading multinational software companies during his tenure, while contributing to the design and implementation of enterprise level performance engineering solutions to enhance the end user satisfaction. So that would be our lineup for PerfUp #4, which is PerfUp edition 4 for today. And before we go into today's sessions, I would like to kindly remind our audience that we always welcome your questions and we encourage your questions. So for questions, we have multiple platforms, we have multiple modes that you can ask your questions. You can directly scan the QR code that is visible on screen right now, or you can also find a link in the chat shortly, which you can access to ask your questions. Or even more conveniently, you can find a tab on our toggle bar today called Slido. If you click on that, you will be directed to a Q&A interface on the Teams application itself. So you have all three modes for your questions, and we highly encourage your questions in our sessions. So without further ado, let's move on to today's main session. I believe Yusuf is ready. So Yusuf, it's over to you.
Yeah. Thanks, Ashwin, and thanks everyone for joining today. So today I'm going to cover a little bit about performance engineering and how performance engineering can help for business growth. So before going to the today's setting, my slides, let me tell you a story. A few years ago, I led a performance engineering team to do a performance testing for a large government agent in Sri Lanka when I was in Sri Lanka. So this is a large government agent. I can't reveal the name. So when I did a performance test with my team on non-prod environment, so we didn't find any issues. So the application achieved the given SLAs. So we thought, okay, this performance of the application is good and we don't have any issues. We can push to the production. So we deployed the system into the production, and within a few minutes, application got crashed. So initially we thought this because of functional issue or functional defect. Then we did a root cause analysis and we found that this mainly because of the load. So the load is coming from production, can't handle to the application. So then we try to simulate this load in non-prod environment, but we couldn't simulate that issue. So we did a performance test at that day, but we did not do a performance engineering. So finally, we realized the issue is not with the our performance test. It's issue with there were two issues. One is with the database design and schema, and second one is the issue with the Tomcat configuration. So, and third one is we did not have application monitoring in non-prod and prod environment. So simply, this is because of we did not have performance engineering. We couldn't find that issue in performance non-prod and our performance test. Yeah, with that, I'm going to little introduce what is performance engineering. So performance engineering has two life cycles. One is development life cycle, other one is operational life cycle. When it comes to the development life cycle, so performance engineering start with the initial phase of the planning a project. So when it comes to the planning project, so a business and engineering teams need to think about their performance of the application, what kind of a users they are going to have, what kind of a performance they are going to give to their users, and what the production load. These things we decide. Think in initial phase. Then other thing, critical aspect is the budget and funding. So when it comes to funding, you need to fund on labor and also tooling. So you can go with open source or license. If you're going with the license, you need to pay for that. So you need to think about that also. Then application designing phase. We need to performance testers or performance engineers need to work with the application architect and development teams to incorporate required performance to the application from designing phase, not end of the development, from designing. So in that designing phase, we need to think about architectural analysis, capacity planning, APM, how we are going to mount our application. Are we going to use open source tool or are we going to use license tool? So if we are going to use open source, what kind of a capabilities that tool has? So these things we will decide. Then test planning and load modeling, these things. Then testing phase. Under the development life cycle, we have testing phase. So we can do different types of test, load test, endurance test, user performance experience. We do at Cisco. So it's a must for you at Cisco. Do a UPX, we call UPX. So for our web applications and dynamic profiling and also network visualization and network latencies. So in large corporations, we host large corporation like Cisco, we host our application in different data centers. For example, our AS400 is in IBM data center in Equinix, US, and our AWS is in uh, US East region. Then we have uh, Azure. So there are different data centers we host our application on different latencies. So network latency is critical. So we need to visualize our network latency. So that's the key in development lifecycle. When it comes to the operation lifecycle, especially application performance management. So, so APM, there's a two stands for APM. One is application performance management and application performance monitoring. So here I'm talking about application performance management. Under the application performance management, we have two part: application monitoring and incident management. As a testers, we have to involve in this phase also. So we need to think what's how we monitor our application in production, how our incidents come to the development channel, to the development teams, how quickly we respond to incidents. So we need to think these things within the performance engineering. Ashwin, next slide. Yeah, I'll like little bit explain about performance testing and performance engineering. So when it comes to the performance testing is a set of practices in which testers simulate real end user load and access pattern in controlled environment to check app speed, stability, scalability. This if we check controlled environment, so we have full control on that environment, and also very limit. We are just simulating the end user. That's in performance testing. And also, typically, performance test results are evaluated depending on the matrices that allow testers to identify and eliminate potential bottlenecks. And also, testing services are limited to testing application with respect to meeting performance requirement. So we have a performance requirement. So we test our application if that requirement is achieved or not. That's the performance testing. When it comes to performance engineering, it's a concept, not a practice. So it comes from architecture. So performance engineering is a concept where different practices, techniques, and activities are performed throughout, from starting to end and in operation phase of the development life cycle to help applications to meet performance requirement. Also, it focuses on designing, architecture, and implementation to build applications that meet high performance standards. So this is the difference between performance testing and performance engineering, or performance testing versus performance engineering. Ashwin, next slide. So why we do performance testing or performance engineering? So normally in performance testing, we do performance testing to find a defect. But when it comes to the performance engineering, so it's not to find the defect, but it's to assure reliability and usability of our product. So if user can't rely on your product, if you can't rely on your product, there's no point of having a product. For example, so you're developing a product, you're pushing, next day break, then there's no point. And also usability. So there can be a nice application UI, but if you can't use it, if it takes minutes to load, then there is no point of having that kind of a product. So performance engineering is not to find the defect, but it is to assure reliability and usability. So there's a big difference with the find defect and assuring reliability and usability. So that's why performance engineering start from designing phase, not the end. So in the designing phase, you are thinking what is the framework to ensure we incorporate reliability and usability in our product, enable reliability and usability. Yeah. Actually, next slide. Yeah, when it comes to the performance engineering or any testing, even quality engineering, so you can't just test and put an application to the production. You need to think about user experience. End of the day, you are doing testing any functional or non-functional. It's for your test users. If you don't think about your user experience, so there's no point of having a testing. So first, for my when I do a test, even now, when I lead a project or when I manage a project, I think who is my users, how they use. For example, so when I was in US, so I travel a lot. So Cisco has internal and external application. So I met lots of customers or application when I uh, travel. For example, Cisco's customers are hotels. So so I speak to them. So how do you feel about application? And so some of these hotels are in remote areas in US, like Sri Lanka. So there are some network issues in remote areas. So we need to think our user, where they from access to our application, how they access, and which kind of a context they have access. For example, my previous company, so when I was Cake Lab, so when I was in US, I went to a restaurant, so I saw that Cake Lab's post. So I asked them how this works. They said it's work perform well even with the in US there are in restaurants there are huge queue. So they said they can manage that queue within a easily with this post. So you need to think about your user, how they use, when they use, and where they use. These kind of thing you think and usability. That's why in UX there are four major factors. One is usability, aesthetics, accessibility, and performance. So performance is key. So you can't compromise your performance. So usability, so when you increase your usability, some people compromise their performance. When they add accessibility to their product, they compromise performance. You can't compromise performance. These four fact, I would say these four pillars are key to the success of application and also key to the UX user experience. So don't compromise usability. Yeah. Then when it comes to the downtime, when applications goes down, there are I found there are three ways that downtime cripple companies. One is bottom line, second one is data loss, and third one is security and compliances. When it comes to the bottom line, so let's say your core system is unavailable. For example, ERP system, if it's unavailable, so it's affect your productivity. Your team will suffer. So company like Cisco, if ERP does not work for 1 hour, it's huge loss for us. So one crippling point is your bottom line, your productivity. So and also you will lose some of your assets if uh, application is down. And also this cost in a large corporation it's hard to calculate. So a company called GlobalScape, they did a survey with 283 IT professionals and the 90% the large corporation. So they found out 90% of organizations have unexpected loss to access to critical system, and nearly a third deal with downtime issues every month. And also, another company did a survey and found out nearly 60% of Fortune 500 companies experience minimum of 1.6 hours of downtime every week. You can think it's a 1 hour is small. No, it's a big for large corporations. Think about if you have a 400,000 restaurants, and if your system is not working for 1.6 hours, then it's almost 1 million hours user going to affect a lot. So for large Fortune 500 companies, it's critical. Down if even if your system is down for 1 hour, it's going to be a big issue. So first critical point is bottom line. Then second one is data loss. Think about Facebook. If Facebook or Google down for 1 hour, how much data is they are going to lose? So they collect our data. So they are going to lose millions of data within 1 hour. So that's one thing we need to think. Then second one is security and compliances. Let's think about OneDrive. We, we all are share our data through our files, photos, everything through OneDrive or Google Drive. Think about OneDrive or Google collapse. Then we had to share our, let's say OneDrive or Google is not there. So we had to share our data or through a thumb drive or any hard disk or emails. It's a there can be security issues and compliance issues. And also large corporations use SMTPs servers which customize for them, and also they have lots of compliances. So if these applications are down, there can be security and compliance issues with their data. So these are the three cripples companies will have within downtime. Yeah, Ashwin. Yeah. So next I'm going to talk about performance versus feature. So this chart or this graph is I targeted for corporate, large corporate. So when it's come to the startup, this other way I'll explain. So for startup, so when your brand and your customer is important. So you can add up features, but because of that feature, if something happens to your system, if system goes down, it's going to impact to your brand name. So for example, so recently Facebook went down. So everyone in the world knew that, most of the people in the world knew that Facebook impact their name, brand. So for the large corporation, if you put that feature versus performance, so I personally recommend performance is important. That's why, for example, you take first quadrant. So performance low and feature low, then application would die. Both not performing well, die. So let's take second one. So vertically up. Let's say feature, we have a rich features, but you don't have a good performance. You don't have good user experience. Then definitely your application will die slowly. So I recommend to go horizontally. So start, put small features while you giving a good performance, good user experience to your customers. Then increase your features. First, put your architecture properly. Put design your application properly to give a good user experience and performance. Then add the features to the applications. That's what I recommend, and I also do for some of my platforms, which we build at Cisco for our quality engineers. Yeah, when it's come to the startup, it's other way. I did not put that here, but startup, the user base is very low. You need to add more features. You can think about performance later. You need to add features a lot. You need to add features quickly to the your application. Otherwise, definitely your application would die. So you can slowly increase your performance while your user base is growing. That I recommend for the startups. So when it's come to the corporates or any company, okay, so have a key for business flows. First one is order to cash. Second one is hire to retire. So third is procure to pay. Fourth is record to report. These are the four business flows in most of the businesses. So each flow has different users. When you design your performance engineering or performance testing, you need to think about users of each business flow. For example, order to cash. So you directly you are exposing your application to the end user who use the application place order. And in the same flow, there can be internal users also. For example, delivery. So delivery application might be used by your driver. So it's an internal user. So I'll tell another story. So I went to a place in US last summer. That means last June. So exactly 1 year ago. So I met a Cisco truck driver. So I had a chat with him. So he said, okay. So he used his mobile phone to access most of his application. And also he, as I mentioned in the previous also, he goes lots of remote areas. So he experienced some issues with application. So he said, since because of he accessing his application through mobile and his mobile is low, not high end. He has a very basic mobile. So he had some performance issues, but he's an internal user, not the external user. So for example, this only in one flow, order to cash flow. Okay, you will have multiple different types of users. Which so when you think about performance, you need to focus on these key flows: order to cash, then high to retire. High to retire flow, there are mostly internal users. Then procure to pay. Procure to pay, internal and external users. So when it comes to external, so mostly procure to pay, those are not your end users, end external users. There's kind of a people who supplies goods for you and who provides services for you. So that's in procure to pay external users. Then when it comes to the record to report, again, it's internal people, but very critical because it's accounting. If something goes wrong in that performance in that area, so it's going to impact a lot on your company. So when when we think about performance engineering, when we design an application, we need to think about these four flows, and we need to think about different users in these flows. That I narrowed it. So how to design your performance, or how to think about performance when you design application, and when you design your performance testing, and how to narrow down your users. So think about these four flows and group it users and how they work within these flows. Yeah, Ashwin, next slide. Yeah. So this is my last slide. So I'm going to hand out Ranil before this one. So after this one. So this is just giving an end-to-end performance testing or performance engineering. So most of the time we do a transaction-based performance testing or performance engineering. When we think about performance, so we think, okay, there's a one page. Okay, we are thinking about performance of that particular page. So it's not the correct way. So when your user, when he come to your application, he come from login page, landing page, then login, search, research. For example, this order to cash. Okay, when place an order. Okay, so he navigate through all this page and he confirm the order. Then he receive the order. So if you're thinking about one page or one transaction, when we do a performance testing, it won't give a good user experience. Think about how your user come to your pay application and how we exit, entry and exit. Think through that. Then think about performance testing. performance engineering. How we are going to model the load. For example, here in this entry and exit. So some people probably exit from choose. They just choose and they exit from your application. That's the one scenario in your performance testing. So some people exit from checkout. Some people exit from after confirm the order. So you need to have a mix of scenarios, end-to-end test scenarios, end-to-end flows. Yeah, that's from my side. So Ranil will talk about more technical aspect of this. I put more concept. So Ranil, over to you.
Thank you, Yusuf, and thank you for laying the foundation from the corporate perspective. Um, yeah, I think hope I am audible. Can you confirm?
Yes, Ranil, you're audible.
Okay. Yeah. So I will be talking about the performance engineering from when it's come to startups and organizations who are not mature, who don't have a mature automation performance engineering model. What kind of how to deliver, how to derive a performance engineering model. So what I'm going to focus. So can you go to the next slide? So first, let's. I think you should also touch on this the importance of having performance. Even when it's come to a startup, also the performance is one aspect which delivers value. It creates a value proposition to the your company. So in that case, that's why it is important to make sure the performance of an application. I'm not going to go much detail on this because already Yusuf also touched on that. But if you look at the left top top kind of thing, then you can see uh, performance basically it involves with the user end user experience, user response times. With the response time deviate with a good response time and bad response time, with that what kind of gains in terms of monetary values, in terms of the revenue expect those company giants, how it impacted. So you can see always if the performance is good, it has created a positive impact. So as you can see in the value positive value creation and propositions underneath it is definitely it the new company, they can gain the competitive advantage and then reach over the rivals and increase the market share likewise. And if you go to the down, if you look at the left bottom graph, it says there's a person called Andy Davis who is a kind of a guru who optimizes sites or the applications to gain better performance to increase the revenue. So he has done his research on the applications where he has worked. This again I have taken from a broadcast from the test guild. So he mentioned that when the response times when the user experience is good, which means the response time is low. When low response time is there, which means that your page is loading and you can do it very quickly. In that case, the probability of users are staying in the your site and going to the subsequent pages are very high. So which again, it gives an indication why performance is better. In that case, the user journey goes beyond the across the other pages, and then more revenue can be gained because users can travel through the other pages without abandoning, without leaving the site. And again, in terms of the right bottom also, by introducing around 4 milliseconds, the line which you can see on the top, introducing 4 milliseconds of application, it has led to increase the 25% of the revenue from which comes from the Android apps. So likewise, the performance is very vital in that case for even for a startup company by complying or uh, by achieving good performance or positive performance. So there are elements of values that can be gained. Can you go to the other slide? Shik? Next slide. Yeah. So performance engineering, again, it's a very vast area. So when it's come to the startup or novice company, so what I'm going to talk about only those areas because due to the time limitations we have. So in that case, these are key areas where most new companies or startups they grappling or they are finding it difficult to find out. Okay, under the performance engineering concept, what we should look at and how. Can you go to the next slide? I will start with the non-functional requirements. So non-functional requirements are the requirements which are input to the to derive a better performance engineering model or better performance testing approach as well. So in that case, when it's come to the new organizations or startups, what questions that they are generally dealing with, okay, who should involve what and why. So when it's come to the who is involving in the to finalize the non-functional requirements, it's a collective responsibility. So when it's come to agile team, it's a different perspective should be involved from the product owner, from the business side, and that because they are the ones who are dealing more closely with the users, but it depends on the nature of the business. Sometimes development teams also, they have a better reach. But generally, from the business perspective, they have a perspective how the growth happens. In that case, with the business growth, how many user base, how it will be increasing, and what kind of due to some advertising or some promotions, the existing what kind of spikes in the user growth could be there. That those information they have better there's a better chance of reach to the product owners and business analysts. They have that aspect. And if it is come to the other part is the development team. Development team always, when they are building the product, as Yusuf also touch on that, at the designing stage, is it is not only the development and the QA engineers as well, QA teams as well, testing team as well. From their perspective, they need some inputs from the non-functional aspects because for their scope with their role, they have certain things to be when scaling down that scaling up the application and when doing certain optimization. They need to look at, or they need to, okay, for what kind of a data load is involved with my feature and what is the user load likewise. So in that case, for that the technical perspective, from the technical perspective also to finalize the NF for non-functional requirement, they have those questions with that non-functional requirements can be finalized because out of that, naturally, what should we look at for the non-functional requirements comes up. For the quality engineering or the testing teams also, it is there to make sure the performance of the application. In that case, okay, what kind of a response time that we need to comply with, and okay, when it's come to the while doing the functional test, okay, they can do some certain understand the functionality with the function. They can see, okay, whether some of the functionalities whether they are within the certain thresholds likewise can be again. So in that case, from their perspective also, there's a need for performance requirements, and then it in return, those will be input to derive the performance non-functional I mean to say non-functional requirement, which is input for the performance engineering. Again, this is we cannot say because it is very difficult to say. Okay, this role, this is for this segment. This is what they will look at. Likewise, that's why I said it is a collective vision because from all this perspective should be come together in order to finalize the performance non-functional requirement. Can you go to the other slide? Okay, now then from the perspective, then what are the areas that you need to look at for performance? What you need, that means what should be treated. So it doesn't mean these are the only things that you need to look at as like finalized as non-functional requirements, but these are some key and common things that any organization can start with. What is the acceptable response time or the response? There could be response time SLA level agreement where your uh, application should adhere. So it is an input for the performance testing process. Okay, during my performance testing, we need to certify this page load time. And again, the concurrent user load and the transaction per second. Concurrent, which means at a given time, your application, how many particular feature for your application, how many users concurrently accessing it and actively using it. That is what you call the concurrent user. That is the figure that you will be simulating in your testing when it's on performance testing phase through the automated testing through the automated script. You simulate this user load. And there's another aspect called transaction per second, which is the when it's come to a particular, which means it's a when it's on a particular flow or particular action, how many actions has been completed within a given second. Again, that's what we call transaction per second. For example, let's say when it's come to a user registration of a, let's say, a student registration system, how many student registrations has been done in a given second. So again, these values, when you are deriving these values, deriving in the sense looking at the values, these getting the averages and maximum of these values. Also, it's good to have those because in that case, by referring them, when it's come to testing phase, then the teams can decide, okay, whether we need to go ahead with the maximum values to average, and based on that, performance tests can be modeled. And the data structure, because the performance engineering, when it's called performance engineering, when you are modeling a performance scenario, the more emphasis is given to simulate the actual user behavior as much as possible. But we cannot mimic the same behavior automatically. It is very impossible. But uh, simulate the real user behavior as much as possible. In that case, that's why we need this information. And again, when a particular, that's why we need to have the insight from the real users perspective, by looking at the production environment data and the customer sites data, what kind of data loads and what kind of data structures they are using. For example, let's say when it's come to a user registration, I'm taking it is a common, very easy scenario where everybody can understand. Or otherwise, let's say completing an assignment and uploading it. So in that case, there could be different sizes of the assignment should be considered. It just not the very. It should be always be looking at what is the average and maximum, and then based on that, it is your input for the performance testing to when you are modeling the performance testing or the performance script to. Okay, we need to simulate this much number of data load because then it gives more flexibility or more chances to predict performance issues or uncover performance issues inside in your testing environments. Again, the workflows having high usage, and it is again, I will cover it a bit more in the next slide. Basically, what flows that we should be performance tested. It's most of the times based on the high usage, but it is not. It is not the only factor. I will cover it next in the next slide. And the number of servers in the production environment, you will again get to know the correlation when I am going to the test environment section in the in the next slides. So which means, because understand the production, what kind of when it's come to the real production environment, real customer side, what kind of infrastructure landscape is there. So now, in terms of the load balancers, how many load balancers, how many servers, likewise, then better to get those information under the non-functional requirement. And again, on top of that, but the CPU, if let's say how many cores are there in the your CPU, and how there are megahertz in terms of megahertz. Okay, how many megahertz, and then the memory limits and memory sizes likewise. Then that also should come in the non-functional test. Then you will realize, okay, why those are important. And along with that, there could be situations where in the production environment, general production environment, generally you see, okay, this is the general pattern or the behavior. Memory CPU memory consumption is around 50%, CPU is around 50%. Those information also better to get as unfunctional required, because sometimes when it's come to the, not sometimes actually, when you are doing the performance testing, you need to you to check, okay, where during your test, the test what you are conducting inside your testing environment, whether they in line with these values. Also, because that is another, because that's why there are some based on some certain changes that you need to adhere to those CPU SLAs. Likewise, where to get those information? That is again from the production environment. You also touched about the application performance monitoring tools. There are tools. There are free tools and licensed tools are there which you need to pay. I have mentioned Splunk and Dynatrace. These are tools which are kind of you need to pay licensing tools, and Prometheus is a on the open source tool. So through this, some of the information you can take graphically, and it is very easy to articulate. Okay, can you go to the previous slide? Yeah, okay. Yeah, I was saying, yeah. And then the not only that, the IIS logs, also you can get the how many hits there are, likewise, and the web server logs, Catalina web server logs, likewise, you can take information, and the database, and there could be several monitoring tools. So yeah, you can collect this information. That's in that cases, that means there will be cases where you don't have those information. That means luxury to access all those information. But in that case, sometimes through that's why from the business perspective, some of the non-functional requirements can be kind of taken. But definitely, most of the companies nowadays, they have these monitoring tools and sources. So those will be those are there. From using them, then you can define the non-functional requirement and finalize, okay, what should be our threshold, what are our SLAs that we need to be adhered in our testing process. Can you go to the next slide, please? Okay. Yeah, so then the next thing is now all, if you remember that I said now we need to simulate the performance scenarios or the workflows as much as possible to the real condition. So in that case, we need to say, okay, what we need to consider as performance scenarios. So realistic performance scenarios. So in that case, this is something I would say where when I say startup companies and the organization, in terms of the organizations who doesn't have a matured performance testing model, this is something you can start with. But with the maturity, then you will realize, okay, what should be looked at. So basically, business critical scenarios, which means the your workflows and the application, there could be features which are very critical, and they have both high usage. So those which mean concurrent user load and the frequency, like PPS wise. So in that case, those scenarios are probable candidate for the performance to be simulated as a performance critical scenario. For example, you can see the examples like when it's come to a healthcare system, patient registration administrations, likewise. And the second one, the features and functions, they generate high revenue to the organization. So those features, the business critical scenarios also comes to that. But I mentioned the high usage, but there could be situations or scenarios where they are not making a high, they don't have a high usage. But in terms of the business revenue, making it is a very critical function, and it could be a kind of a downstreaming or dependent system for a high usage functionality as well. Classic example is when it's come to e-learning platforms, where I have worked course creation, because users needs to be enrolled to the course, because without the course, you cannot, without enrolling the course, you cannot make revenue. So it is but in terms of the user load, user concurrency, it is very low. But anyway, in terms of the revenue generation, it's very critical. That's why we need to consider it as a function candidate for a performance scenario or a work. Again, there could be features or functionalities which are very from the technical side, they are complex, and from the architectural side, they should be included or they should be looked at in the covered during a performance test. For example, there could be some integration points of wormhole systems where when integrations goes through, when integrations go through a particular system. Likewise, those areas needs to be covered. That's why it is, again, it's based on the context and the architecture of the application, but these are kind of key the key guidelines there. You can start it to understand what we should look at as performance when it's come to performance testing scenarios. Yeah, can you go to the next slide, please? Before I start here with the performance test environment, I will, if you remember, when it's come to the non-functional requirement section, I mentioned that what should we look at, user load, TPS, likewise, because they generally, when we are concluding a performance testing or saying, okay, whether our application can go to the live environment or not, when we are certifying the product from the performance perspective, those non-functional requirements are the base to decide, okay, whether our application is good enough to release to the production environment. So that's why if the response times are not achieving, then yes, it's a question. And if the CPU and those thresholds are exceeding and there's a bottleneck, yes, then again, this is there's a problem. So that's why the non-functional requirements are very crucial and critical. And it, at the end of the day, it will be a key performance indicator to make sure or rather decide whether the system is behaving properly in terms of performance. Okay, performance test environment. Now, all the time we have been talking about how to articulate your performance testing, performance scenarios in a realistic way by referring the non-functional requirements. Now, if we are to then when we are in order to uncover performance issues in your test environment, then we need to have a proper testing environment. But anyway, for the most of the new organization, even for the matured organization, or I think mostly large corporates, they have the luxury. But due to the budgeting restrictions, you cannot have the same exact replica of the production environment. So in that case, because when you have the exact replica of the production environment, the chances of creating the performance issues or uncovering performance issues and predicting performance issues happening in the production environment, there's a high chance. But there's a practical limitation that we need to deal with. So how then okay, then we need to have a proper performance testing environment. We cannot take the exact replica of production environment. What kind of options we have in this case? The best of this is a kind of a we call it an extrapolation method, but there are very scientific ways that you can extrapolation methods are there that you can derive your testing environment. But I am talking about a very simple but a proven method that you can go ahead. You in the sense for a new organization startup. So what you can do is you can scale down your production environment, derive a scale down environment of your production environment based on a ratio. So it's for example, one third, and one third would be a kind of a good ratio, because if you can reduce the ratio, in that case, there's a high chance that you can have a good environment and kind of identical to the production environment and chances of recreating performance issues. So at least one third is good. For example, let's see. Okay, what it means by one third? Let's assume your live environment, customers' real environment. It has 9 application servers and 3 load balancers and 3 databases. In that case, based on the one third ratio, then what you can do is you can create your test environment that is include 3 application servers, 1 load balancer, and 1 database likewise. But this you have to be careful in, because based on the application, the dynamics in the architecture, you need to see, okay, whether we can extrapolate or whether can scale it down in the same manner. But as much as possible, you can scale it, try to scale it, but with the but considering the dynamics of the architecture, because there could be sometimes having one database, not enough, 2 databases needed based on the functions that you need to be performance tested. But based on this kind of a ratio basis, then you can set up your environment. But we are talking about horizontal scaling, which means reducing the number of servers. The other important things that you need to make sure in such a scenario, this kind of a scale down scenario, is the configurations and setting of the servers, like CPU limits and the memory sizes and everything should be identical to the production, the given server, what you application server, what you see in the production. The same CPU and CPU core sizes, CPU level, and the memory levels should be reflected inside the your environment testing environments, application servers, because we are just talking about the horizontal reduction, reducing the number of servers, not the vertical, not reducing the servers settings and the sizes. So in that case, because you have environment which has a kind of comparable environment, which is scaled down to the production environment. And again, the software and hardware settings configuration should be identical to the production environment. But there could be situations, some of the settings with if they need to reduce with the user load. I will come to that. Let's say in this scenario, again, since we scale down the number of servers, then we need to scale down based on our ratio, one third ratio, scale down the number of users for the TPS. Let's assume if it is 900 concurrent users are there in your production environment for particular feature that you need to conduct performance testing, then it should be scaled down with this ratio, which is 300. If there are settings which needs to be scaled down because of the reduction of the number of users, then it should be, or like there could be U limit kind of thing, which would be there, the session number of sessions supporting sessions kind of things should, with the along with the reduction of the user load, if they need to be reduced, those type of settings should be reduced as well. And the other key thing is this kind of environment, because you are doing testing in a pre-production environment or testing environment. This environment should be um, um, uh, should be kind of built top of on top of on top of in the sense actually this should be in a dedicated setup, which means this environment should be dedicated for performance testing, and this environment resources that is CPU, memory, and if it is hosted in a VM or cloud machine, then those shouldn't be shared during the, at least during the day. Ideal scenario is every time those shouldn't be shared. It should be meant to be for the performance testing. Otherwise, if it is being shared with the other machines in the cluster or other resources in the same VM machine or cloud cluster, then in that case, the it can have a negative impact on the disturbance or the noise on the performance test results, which is ultimately you will get inconclusive results. That's why you need to have a dedicated environment when you are deriving a performance environment in such nature. Yeah, so that is again very important. Those are three things that you need to adhere when you are deriving a performance testing environment. Yeah, can we go to the next slide? Um, I'm not sure whether I can. Yeah, okay, now I can see that. Now, when it's come to the testing process, now we have the test environment, realistic performance scenarios, everything in place. Okay, now how we, when it's our testing process, I think it's a keyword, right? These days, shift left testing. So it applies to the performance testing because when it's come to the development life cycles, if we can find the issues at the early stages of development life cycle, which is at the left side, when you think about the V model. So then fixing the cost is very low, fixing them, and it's very easy to fix them. So it applies to the performance testing as well, performance testing process under the performance engineering umbrella. So what then there could be a process can be implemented during the development time, development phase. Method level profile, which means the code once a developer does a code change, if he determined, okay, yes, there could be a performance issue, because if they determine, yes, there could be a performance impact for that, then in that case, by conducting a method level profiling, then they can compare, okay, before the change, after the change, okay, how were the methods response time and whether there are unnecessary calls or there, and whether likewise through the profiling tool itself, you can find out at the development stage, at the coding stage itself. For that, you can use UOKit, JProfile, those are and the Dynatrace, those are some of the tools which are license based, but there are the open source tools are there as well, good open source tools. And the other thing is the web browser profiling. That means when you are when it's come to the web browser side, there could be certain logics that simulates at the web browser side only, because most of the times from the tools what they get, JMeter, likewise those tools, they those performance tools, most of the times they stress the server side only, not the client side or the browser side. So, but there could be logics that which happens at the browser side, and it in return lead need to have a good or bad page load time. So those can be verified by simply carrying out a code browser level client side profiling at the development stage itself, the tools are like you can get the voice flow and page speed and developer from developer tools are there. And again, at the same time, once the feature is completed through the single user based performance comparison, which means that particular performance flow can be executed at the same time through proxy tools like Fiddler. The response time can be captured. And then you can, the developer itself within the given environment, they can see, okay, whether they see a drastic response time difference. Let's say they see a 10 millisecond difference. Then it gives a indication, okay, now with the higher load, definitely there would be a problem. So then they can dig down the issue and see, okay, where the issue is by doing a couple of test runs and by after doing code level profiling and so on. And the next one is the again we can have a smoke test suite which is very lightweight test suite integrated with the Jenkins, which means to make sure to verify your build in terms of performance. Then by executing when a particular build is build verification, build is deployed to the testing branch. This particular smoke test suite can be executed very quickly. Let's assume it's very within half a 20 to half an hour, maybe less than that. So this from that, then it gives an early indication of whether your build is good enough from the performance perspective. So in that case, if it is good enough only, then the subsequent stages can be gone. Again, its early indication can be taken. You can execute it nightly, also maybe based on a code commit. Um, in the staging environment, then it comes to the staging environment where the actual testing happens. So at this stage also, the organizations can derive a testing methodology or performance testing approach here based on the impact of the particular change. Targeting that particular change, they can execute different testing from ranging from the load testing, stress testing based on the impact. And then again, that is targeting the specific change. There could be, I think most organizations, they have several features across their product or their application. So in that case, from all features, they always, from the all module teams, then they, from those teams, they always make changes. And due to the changes, there could be situations, it impacts to the other modules, like we call this a regression. The same can be applied in the performance arena as well. You can have a performance regression suite, which is a suite which covers or which uncovers the problems of the overall product. So as a whole, then you can see how your product is behaving in terms of performance when all the changes are there. So by executing that the performance regression suite before your product is going to the live environment, it is not targeting a specific change but overall. Then you can find out the stability of your product and how performant is your product. You can get a historical data as well at each build that you can see. Okay, how whether they are aligning with the performance metrics, whether we can uh, pass it to the, or whether we can release to production or not. So again, the same can be used, those performance metrics as we call response times and so on, and the CPU and memory threshold. It is better if you can come up with a dashboard or something that you can compare with the baseline and after that. Most of the application performance monitoring tools, they cater. Otherwise, they are by using Grafana dashboards or those representation tools, you can take this information to the to a dashboard and compare, because it is easy for everybody to look at, and then even not through a centralized performance test team, even from the module level itself, they can look at, okay, what is the performance behavior of my application. Can you go to the next slide, please? This is a slide which I was explaining. So about if you can visualize the performance matrices in a single node, like in my organizations we have something this, but it doesn't mean everybody can come up with this based on the nature of the application and the based on the what kind of this is for a for a Java Swing client for the client side. We compare with the baseline, okay, what where performance matrices, and very easily we can find out where is the issue. And after that, we drilled out, what has been caused. So this is about all about the what I wanted to cover, because as I said, it is a very vast area, but still um, uh, I covered some of the key areas that should be more important to the organization. I think Yusuf then covered about the when it's come to the monitoring side, where the shift right aspect as well. So I think combining the shift left and shift right, you can come up with a very good sound performance engineering model. So I believe this is something beneficial for the startup companies, or at least they can start with, and after that, with the maturity, then they can mature their performance engineering process. Okay, thank you.
Thank you very much, Ronald. Thank you for your insights, and thank you to Yusuf as well. Both of your wonderful insights on performance engineering, and thank you for your valuable time as well. So, quick reminder to the audience: you can straight away direct your questions to both Yusuf and Ranil. So we already have a couple of questions. So let's just move on to the first couple of questions while the rest of y'all can direct your questions further ahead. So um, yes, let me start off with a question that's directed specifically for Yusuf. So the question would be, how did you identify the root cause for the issue which did not report in testing environment? What are the practices we can follow in such a situation? Let me repeat the question, Yusuf. How did you identify the root cause for the issue which did not report in testing environment? What are the practices we can follow in such situations?
Yeah, first of all, I would uh, go to the application performance monitoring tool. So that commercial application monitoring tools give your exact root cause where it's what's the wrong with tools like Dynatrace, Datadogs, very advanced tools. You can profile your issues up to the database level. So if you don't have any that kind of luxurious tools, so what I'm thinking as a tester, so you get the take the issues and analyze the data specifically when this issue happened, what's the peak or what's the load when these issues happen, what kind of a data they have used, and also what's the environment capacity when these issues happened, and also uh, you need to check the application hosting. I think like Tomcat or any currently Node.js.net. Sorry, those things you need to verify those configuration of hosting tools. So if you still you couldn't find the issue, I would like you to monitor the application manually while these issues happens. Yeah, try to recreate these issues. Yeah.
Thank you very much for that, Yusuf. I hope our audience received the answer they expected. So we have a few more questions coming up. Yes, our next question would be common. So in startups or smaller scale organizations per se, how can we model performance test? Because it will be difficult to build a product like control environment due to high cost is their reasoning behind the question. So the question is actually how in startups and smaller scale organizations they can perform model performance. They can perform model performance tests. Ranil, you're on mute.
Sorry about that. Yeah, in the presentation, I think deriving a scale down environment, that is the place where I covered it, because you can derive a scale down environment. In that case, you can come up with an, but still, if it is still costly, what you can do is a kind of a approach. What you can follow is then you can come up with a particular environment based on by looking at the production environment, at least come up with the environment which is civil in the sense in terms of the configurations and the CPU core sizes and likewise the memory sizes, and set up an environment based on your capability. And then in that case, what you have to do is you have to baseline your test, always take a baseline. And after that, when you are doing a test based on the change, every time you can compare. By that, then you can see whether there's a declaration. If there's a declaration, for in that case, inside that environment, what kind of what should be the effective uh, performance SL or other the response time SLA or response time. Those should be first finalized. It based on again, then based on the it is very hard to find if you are coming with a very too very narrow environment or very slow, very small environment. So in that case, it's always you. That's why you have to start with the baseline and see, okay, what's the number? What you have to baseline the response times and whatever things what you are taking, and thereafter keep on when you are doing the test. Again, after changes, then you can compare. But for the comparison, then you can have a threshold. Okay, at least in my there should be a decrease or the increase of at least 5% or 10%. Likewise, decrease or deviation should not be there. Like you have to come up with a sensible threshold levels, which is applicable to environment. Through that, it is another way how you can make sure to conduct a performance test when you don't have a luxury to buy a or scale down environment. Even you cannot get a scale down environment. I hope I answered the question.
Yes, thank you very much for that very elaborative answer. So, yes, we have a few more questions. There's a request if either of you can share your thoughts on how we can uh, model perform test data when we do not have visibility to the production data. I believe the question was clear. Can you share your thoughts how we can model performance test data when we do not have visibility to the production data?
So let me answer that. So this, I hope they're talking about the test data which used for the performance testing. So you can first you need to identify your master data. What are the master data you want for your performance testing? So that easily you can identify with your knowledge with the domain. Then once you identify the master data, then you need to identify the transactional data. So mostly performance, when performance testing, you need a lot of transactional data. So this transactional data, I think, sometimes tie with the master data. So with your again knowledge with your functional and domain, so you need to create that transactional data. And again, if you can't generate or if you can't create data, for example, so if you can't use production data, if you can't use real customers data, better to generate the test data using your own script. When you generate the data, need to be very careful. So if you just use insert query, you might crash your application and database. So I recommend to generate data using APIs or UI. That's my recommendation. But if it's not possible, use the queries.
Right, thank you very much for that answer, Yusuf. We have two more final questions. So I'll go with the next question. The next question would be any industry standards or rationality on setting up the environments or use test environments for performance. Any industry standards or rationality on setting up the environments to test is the question.
Um, Let me try and maybe Yusuf, do you have anything or shall I try and hand over to you? Yeah.
Yeah, Rana, you can try and if
Yeah.
anything.
Okay. Yeah. To my knowledge, I think there are extrapolation techniques are there. So when you look at, I think you can see that there are scientific extrapolation techniques when setting up a production civil environment, what needs to be looked at. So it's a more based on some mathematical equations based likewise. So I those kind of, but I don't have visibility to say point, okay, this is the exact methodology that you need to go ahead. So that's why something what I have been experiencing, what I have been by looking at by sharing the experience with the performance people who are doing performance testing in the industry, extra scaling down in a ratio basis. It's a kind of it's a standard. I would say it's a standard in the means like a very formal standard, but it's a standard that in the day-to-day environment, day-to-day works, that performance parties who are working in the performance testing process who are following. So yeah, that is from my side, I would say.
Yeah, adding to that, so there can be two types of environment you can have. One is actually you can't if you are testing kind of end-to-end performance testing, you might need multiple applications or components. So in that case, try to simulate as much as possible. If not, uh, introduce the actual uh, environments. So if you are using just kind of a single application, if you're doing a performance testing for single application, so it's easy. You don't need to do a simulation. You can just, as Randall mentioned, scale down your application or environment, and again, you can do that. You can use that. Yeah.
Thank you very much
Just
for those answers. And yeah, sure, Anil.
Yeah, sorry, actually. So something just came to my mind, occurred to my mind that there are some organizations who I think for the startups, I'm not sure whether it's possible, but organizations who are mature performance testing process, they straight away conduct testing on the performance production environment as well. So in that case, that also a kind of a way where you can conduct your performance test, but it should be a very very organized process. Otherwise, production environment can be broken down. So that's another aspect you can look at. Yeah.
Right, thank you. So we have two more questions related to front-end performance testing. So the first would first asks when it comes to front-end UI performance, what are the approaches we can use? I believe it's in testing aspect. And then there's also another question that says, can you explain approaches for specifically mobile front-end performance testing? So it's all related to front-end performance testing. So what are your thoughts on that, gentlemen?
Um, for when it's come to the front-end UI performance testing, I think as I mentioned in my slide, what you can do is there are tools like developer tools which comes with the Chrome developer tools, and there are tools like Page, Wiselo, PageSpeed, and the Lighthouse. those Google-based those tools, they give a lot of information about doing front-end profiling, and then you can take the what you can do. It just simulate the particular flow by enabling that particular tool on your browser. Then it gives the report, and especially the Lighthouse, it gives the report what components impacted to get a high page load time in terms of CSS minification, in terms of the if they are the how about the image rendering has been impacted, image size has been impacted for front end page load time. Likewise, you can get those information. I think when it comes to UI front end performance, the question was what approaches. Um, that's the approach that you, and again, there are right now some of the commercial tools like Load Runner and even in JMeet open source tools, there are some protocols you can use to measure the performance of the UI side. But they don't have all the features to some extent. Using true client kind of protocols, you can measure. But again, I think mostly in the industry, those front-end profiling tools like Wiselow, PageSpeed, especially Lighthouse, those are being used right now. That is, I think, for the front-end profiling. For the mobile front-end performance testing also, I think based on the what kind of a protocol, based on the protocol, you can use some of the this Lighthouse also to some extent they are supporting, but tools like Appium, I think they have separate protocols for that, but those are licensing tools where you can then get the okay, when it's come to the front end side, what kind of it gives okay from which layer what component has taken time to load your page or load your application. Yeah, Yusuf, if you have anything to add, you can.
Yeah, for mobile especially, I just want to highlight that think about the bandwidth of your carrier. So don't use your office Wi-Fi when you do a performance, doing your performance testing for mobile. Try to simulate that kind of a real world scenarios, and don't stick to a one carrier. Try to use multiple carriers, and also when we select a device, okay, think about usage of that particular country. For example, if your applications for US, think about that mobile, I think, usage or mobile device usage of that particular country, and based on that, decide what are the devices I need to use for performance testing. Then again, from tooling point of view, for client-side profiling, you can use Android Studio and also Xcode. So they have good profiling tools. So you can use that. Those are, you don't need to pay extra if you have Apple laptops. You can use Xcode. If Android is open source. Yeah.
Right. Thank you very much on that. So, considering the interest of time, we'll be going on to the last question of our Q&A session for the day. So, this is with relevance to one of the previously answered questions, I believed. So, the question is, in a startup, if you are not given performance requirements, then what would be the approach to do a performance testing if you're allocated to do a performance testing? So, in a startup, if you're not given the performance requirements, what would be the approach to do a performance testing is the question.
Uh, yeah, I think it's a very tricky situation. In that case, if you have channels to talk with your customer, I think most of the you can have interaction with your customer by you can go up with some of the questions. Okay, what kind of a user load at a given time? What is the user load that you see? How many users can use this particular functionality? Or you can ask if you remember I said what are the things that you need to consider when selecting a performance scenario. Based on that, you can ask questions from the customer, and then you can articulate, come up with some information. Okay, these are the non-functional requirement at least. So in that case, thereafter you can have a kind of a agreement with the customer. Okay, these we will be getting or treating as non-functional requirement in terms of load, concurrent user load, or the response time. Uh, there could be some situations where if you have a rival or by looking at the rival's application, there could be sometimes those there are sources that you can find out. Okay, they are certified this kind of a response time. They are adhere to this kind of response time. They also in a kind of input for you to see, okay, for my application also based on my context, whether we can kind of go ahead with that. But the best thing is to make a conversation, have a kind of start a conversation with the customer, the end user, or the whatever the contact you have. From them, get those questions answered. Through that, then come up, finalize the values, and then agree the values, and then start your testing process. Yeah, that's my 2 cents on that.
Okay, thank you very much, Ranil, for answering the final question, and thank you to Yusuf and Ranil both for taking extended time into answering the questions of our audience. So, simply due to uh, the interest of time, although we would like to receive more questions, uh, we are we are well behind schedule. Uh, so we would like to inform the audience that if you have any further questions regarding this matter, please direct it us to the PerfUp team, and we'll be overwhelmed to provide answers to you in any possible way in the future. So with that, I would like to come to the conclusion of the event. Thanks to everyone for being here with us and being a part of today's event and making this a success. And very specially, I would like to thank the two gentlemen, the two speakers. We really appreciate yet invaluable time and effort into joining into our session and educating the audience on performance testing and all the matters. So again, I would like to repeat additionally, if you have any other questions, just reach us out via the Cisco Labs social media profiles or even on our meetup page, and we will try our level best to answer all of them. And also one last comment. So there will be a feedback form available in the chat of this meeting. So you can go to the feedback, and we would really value your feedback for us to try and make PerfUp Edition 5 even better. So please take a few minutes into going into the feedback form and providing your response kindly. So that comes to the end of today's session. Thanks again to the speakers, and thank you for a lovely audience today, and to everyone that joined. Hope you have a good night and stay safe all. Thank you. Thank you very much.